Hello everyone. Welcome back to Textbook to Classroom CS. In the previous videos, we understood what a DBMS is and we also saw the different uses of a database system. So now in this video, we are going to understand a very important topic that is file system versus DBMS. Actually, before DBMS became popular, many organizations used ordinary files to store data. For example, marks may be stored in one Excel file, attendance may be stored in another file, and fee details may be stored in another file, and student details may be stored somewhere else. So at the beginning, this may look simple, but when the data becomes large and many people start using the same data, many problems will slowly come. So, today we are going to compare the old file based approach with the DBMS approach. So, we will use a simple college example throughout this video so it will be easy to understand. Okay, first let us see what we are going to learn today. So, by the end of this video, you should understand what the file system approach is. Then you should understand why files become difficult to manage when data grows. And we will also see the common problems in the file system approach, like data redundancy, inconsistency, security issues, sharing problems, maybe the backup problems, and accessing problems. After that, we will see how DBMS solves many of these examples. And finally, we will do a small classroom demo using student data. So imagine college managing student data. In a college, we have many types of information, right? For example, student details like student ID, name, and department. Then marks details like subject, marks, grade, etc. And the attendance details like date, period, and present or the absent status. Then the fee details like amount, due amount, and the paid status, something like this. So now, if the college stores all these details in separate files, at first it may look very easy. So one file for student details and another file for marks and one file for attendance and maybe another file for fees. Slowly, when the number of students increases and many staff members use these files, problems will start. So the same student name may be repeated in many files, right? The same department may be repeated in many files. The same phone number may be repeated in many files. So the main question is what happens when data grows and many people use it? That's exactly what we are going to understand in this video. Now, let us understand what the file system approach means. So, in the file system approach, data is stored in separate files. For example, we can say student details may be stored in student.csv and the marks details may be stored in another format like marks.xlsx and attendance may be stored in a text document and fees may be stored in fees.doc, that is a Word document, or in another spreadsheet. So basically, each department or each office may maintain its own data, right? So for very small data, that is not wrong. For example, if I'm storing my personal notes or a small list of names, file is enough, right? When the data becomes large, important, and shared by many users, this approach becomes difficult. For example, in a college, the same student data may be needed by the exam cell, accounts office, or the department office, or library, or we can say the placement cell. If each one maintains a separate file, then managing the data becomes very hard. So the file system is not completely wrong. So it is useful for simple personal storage, but it is limited for large, shared, and for the important data. Now we will see what are the major problems of the traditional file systems. The first one is the data redundancy. So, what is data redundancy? That means the data is repeated in many places. Okay, for example, in a student file, we may have student ID 101. The student name is Anu, belongs to the department CSC, and her phone number. So in the marks file also, we may again store Anu's name and department. And in the same fees file also, we may again store Anu's name and department. So the same data is repeated again and again. Now, some students may think, what is the problem if data is repeated? Right. So there are mainly two problems. The first one is it wastes storage space. That is one small issue. But the more important issue is that repetition increases the chances of mistakes. So if the same information is stored in five different files, then any change should be updated in all five places. If we forget to update in one place, what will happen? Then the data becomes incorrect. So, data redundancy means unnecessary repetition of data and it can lead to other problems too. The next problem with the traditional file system is data inconsistency. So, data inconsistency happens when the same data has different values in different files. So, we can look at this example. In a student file, Anu's department is CSC. Okay. But in the marks file, by mistake, Anu's department is entered as IT. And in the attendance file, it is again CSC. Okay, now the same student has different department values in different file. So which one is correct? This confusion is called data inconsistency. Usually this happens because the same data is repeated in many places. One file may be updated, but another may not be updated. That's the reason for that. Another example, consider a student Ravi. If Ravi changes his phone number, the phone number should be updated in the student file, marks file, whatever the files like fees file or attendance file and other places. If you update only one file and forget the others, inconsistency will happen. So remember this important connection. So data redundancy, we know that is repetition of data. So what it leads to is data redundancy leads to the data inconsistency, right? Now, let us see another important problem that is difficulty in accessing data. So, in a file system, simple data may be easy to see, but when we ask a combined question, it makes difficult, right? For example, suppose we ask, find all the CSC students who scored above 80 percentage marks and have attendance below 75 percentage. Now, where is the data? Student department may be in the student file. We can get it from there. Marks may be in the marks file. Attendance may be in the attendance file. So we have to open multiple files, filter the marks, filter the attendance, and then match the student ID and compile the results manually. And moreover, this takes time. Also, there's a chance of human error, right? But In a DBMS, this type of question can be answered using a single query. So we can ask the DBMS to combine the related tables and retrieve the exact result. So we can say in a file system, accessing combined information is difficult, but in DBMS, query based access makes it more easier. Next problem is data isolation. Now, uh, data isolation means data scattered in different places and different formats. For example, marks may be in Excel format, fees may be in a Word document, then attendance may be in a text file, then library records may be in a CSV file, there may be old backup file in another folder. Now, if data is scattered like this, with the files of different format, connecting all the information becomes difficult. Suppose we want to connect library fine details with student attendance and fee payment. If all these are in different formats and different files, it becomes complicated. This is called data isolation. In DBMS, related data is kept under one managed system. It is usually stored in proper tables, and those tables are connected using relationships. So, DBMS reduces the problem of scattered and isolated data. Then the next important issue is the security issues. In any organization, everyone should have the same access. For example, in a college, a student should be able to view only their own marks and um, attendance. Sorry, in any organization, everyone should not have the same access, right? For example, because we cannot give the same access to all the stakeholders. So, for example, students should be able to view only their own marks and attendance. And when we consider the faculty, they may be allowed to enter or update the marks. The same access is not given to the student. So it is a problem, right? We cannot give the same access to the student. And then admin staff for the DBA, that is database administrators, may have the permission to generate the reports, manage accounts, and take backups. Now, in a simple file system, it is difficult to control access at this detailed level. So, if someone gets access to the marks, they may see more information than needed. For example, the marks file may also contain phone numbers, department details, or maybe other personal informations too. But in DBMS, we can create user accounts, roles, and permissions. We can control who can view the data, who can update the data, and who can delete and who can manage the data. So DBMS gives better security and access control compared to the ordinary file systems. The next one is the important problem, that is sharing and concurrent access. So concurrent access means many users are accessing or updating the data at the same time. That is said to be concurrent access. Let us take a railway or airline booking system, that example. Suppose we can say seat number 21 is available. Let's say user A tries to book seat 21. At the same time, user B also tries to book the same seat, that is 21. So, if the system is not properly managed, both may get the same seat, right? Then it will lead to confusion. So, that is a wrong result, and this is called an anomalous result. In a simple file system, handling many users at the same time is difficult. But DBMS has mechanisms to control simultaneous access. It can make sure that one seat is booked only once. So when many users share the same data, DBMS is much safer and it is considered as more reliable. And the next one is the important problem, that is backup, recovery, and integrity. So, first, backup. Okay, so important data needs backup, right? So, if files are deleted, corrupted, or lost, maybe physical damage, so recovery may become difficult in a file system. And the next one, the integrity problem. Integrity means correctness and validity of data, right? For example, marks should not be negative. Attendance percentage should not be more than 100. So date of birth should be a valid date. So it is having some specific format, right? So student ID should not be empty. So, and what is the second one is the recovery. Suppose the system crashes while updating marks or the fee payment details. After restarting, the system should restore correct data. A DBMS provide better recovery mechanisms. So backup, recovery, and integrity also should be considered, right? So in a simple file system, it is harder to enforce all these rules properly. But DBMS allow us to define constraints and rules to maintain data quality. So we can say DBMS helps protect data through backup, recovery, and integrity rules. So I'm going to end this video here, and the remaining about the same topic I'll continue in the next video. Thanks for watching.